again! Hopefully you had a chance to watch my previous video on accuracy and precision before proceeding on to significant figures. In this video, there are places where I'll tell you to pause the video. Pause the video, then you can try the example. We go over the example together to see how you did. Alrighty, significant figures. Before we talk about some of the rules in significant figures, I just want to give us a little thought about places where you might see significant figures. Let's say you're trying to measure, or you don't have a ruler, but you want to know the length of this line. You only have your naked eye to measure, but so the best that we can do is make an estimate. So let's make an estimate. Here's a chance to pause, just make your estimate. I'm gonna make my estimate here as, of course, it might not be the same as yours, and that's okay. I'm going to say this is roughly 15 centimeters. Maybe you had something else. Maybe some of you may have had roughly 10, or some of you may have been more detailed, saying that is 17.5 centimeters, or even adding a few more decimal places after that. Now, here's my question for you. Are you actually confident that your eyes are able to estimate down to the 10,000s place? So how do we show our confidence in our measurements, in our readings? Well, being honest scientists, we want to make sure we communicate our experimental results to the level of precision that we're confident with. If you're not confident up to the 10,000s place or whatnot, then it's probably, as an honest scientist, we don't want to write all these digits that could be potentially false. Maybe the best guess of the length of this page might be roughly 20 centimeters or 10 to 20 centimeters. As for me, it was already hard to estimate down to the ones place. Notice that in 20, there's only one digit here that we're working with, as opposed to here we have many digits that we seem to be confident with. With these confident digits, these are called significant figures. The more significant figures you have in a number, it shows your confidence in the precision in the measurement. More significant figures, more precision. Let's take a look at the rules of significant figures. How can we determine how many significant figures a number has? There's a few ground rules. Let's start with the very obvious one. Number 1, all non-zero digits are significant. If you see any number that's not a zero, they are significant. So we have 8,492. 8,492, we have a total of 4 sig figs over here. So that's another way to show. It's a shorthand for significant figures. Here's writing just sig figs. Now it's your turn to try. We have 948,721. Here's a good time to pause and we'll come back. Okay, going over this, we have 9, 4, 8, so 3, 4, 5, 6, total of 6 sig figs. Number 2. Now we dealt with non-zero numbers, but what about zero digits? Zero digits are oftentimes not significant, but there are cases where they are significant, and we'll look at those examples. For number 3, for non-decimal numbers greater than 1, so here we have 440,000, that's a non-decimal number, no decimal here. It's greater than 1. We say that all zeros to the right of the last non-digit are not significant. Okay, so a lot of words. We'll break it down by looking at our first example. How many significant figures are in this number? We say that all zeros on the right of the last non-zero digit, in this case, the last non-zero digit is our 4 in this place. Every zero to the right of that are not significant. So starting from here, everything after that, these zeros are not significant. I like to think of it this way. Let's write the number down again. I like to think of it as I'm taking a pair of scissors and I'm going to chop off every zero that's not significant. So I'm going to cut, and every time I see a zero, I'm going to cut until I see the first non-zero digit. So all of these zeros are not significant. In this case, we're left with 2 sig figs. I'm going to give you a chance to try the next example on your own. Coming back together, how many sig figs are in 1,099,800? So again, I'm going to use my scissors method. 199800. Taking our pair of scissors, and we're going to cut. Oh, we meet the first non-zero digit. We're going to stop right here. These zeros are not significant. We're left with 1, 2, 3, 4, 5 significant figures, sig figs. Alrighty, moving on. I know hopefully I'm not going too fast. I do have to make sure this video is under the 15-minute limit by YouTube. So moving on to number 4. We've dealt with a non-decimal number greater than 1, but what about a decimal number greater than 1? If that's the case, all our zeros are significant. So in this example, how many significant figures are in 20.098? All of them are. They are all significant, including the zeros in between, because they're part of the number. Okay, they're not used to communicate precision. So we count them up. 1, 2, 3, 4, 5. We have here 5 sig figs. Okay. Give you a minute to try this one on your own, so pause your video. Welcome back, and we're going to go over this example together. Again, if we have a decimal, all of the digits are significant. We count 1, 2, 3, 4, 5, 6. We have a total of 6 sig figs. Now, you might have been thinking, well, what about this 0 here at the very end? Don't I use my scissors method for that one? But in fact, because there is the decimal, because of that decimal, all of our digits are significant, including that 0. Why is this? So using the decimal can be very useful at times, because I'm going to give us an example. Let's say you measured 100 centimeters and you wanted to represent that as 3 sig figs and not 1 sig fig. The way to make this look like 3 sig figs is to write that decimal in front of that 0, which then gives you 3 sig figs. Okay? So sometimes if your measurement exactly 100, you need to represent 3 sig figs. That's the way to do it. Also, we can represent this as, or you can represent this as using scientific notation. This is the reason why we learned about scientific notation in the first place. It's a good way to help you represent the number of sig figs as well. Okay, so these are examples of how you can use the decimal to help you communicate how many sig figs you want. Okay, those are some side examples. But moving on, for decimal numbers less than 1, so we dealt with numbers all greater than 1. What about numbers that are less than 1? If they are, then all zeros to the left of the first non-zero digit are not significant. Okay, that's a mouthful. Okay, let's use that in our next example. How many sig figs are in 0.12345 zeros, 99 and 998? We look at the first non-zero digit, so that's our 9 right here. That is our 9. All the zeros to the left of that number are not significant. So we take this 9 and everything to that left of that, these are not significant. Again, I like to use a scissors method to help you count. So writing this down, 0.123459998. We take a pair of scissors and we cut. Bam, 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 bam. Oh, we see the first non-zero digit, and notice I'm cutting from the left side, not from the right side when dealing with a decimal. So in this case, we take away all these zeros. These are not significant, and as a result, we're left with 3 sig figs. Yummy figs. Alrighty, here's a chance to pause the video and try the next example on your own. Coming back together. Let's use that cutting way. I'm going to write 0.123290100. Let's take a pair of scissors. This time we're dealing with a decimal, so we're going to cut from the left side. So we're going to cut. Oh, we see the zeros. Chop, 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 chop. Okay, we see our first non-zero digit, which is our 2. We stop. All of these zeros are not insignificant. We are left with 1, 2, 3, 4, 5, 6 sig figs again. Now you probably would be wondering, what about these zeros that are over here? Are these guys significant as well? Now, because we're dealing with a decimal, as we are cutting from the left side, these zeros do not get chopped off as a rule. But there's an important reason why they don't get chopped off, and that we have to scroll down to the bottom when we talk about how is it conceptually important for them to be there. How do these rules work? Well, you really have to think of anyone, the person who's writing this number as a lazy but accurate person. A lazy but accurate person is not going to want to do extra work. So taking an example of this number up here, notice how that is very much sufficient to write this number as, let me get the right pen, why not write this number as 0.1232901. Why do I have to write these zeros? Well, the zeros are there for a reason. They must be there for a particular reason, which means the person writing them down must be trying to communicate something. What are they trying to communicate? They're trying to communicate precision. So these zeros must be important. They are significant. So a lazy person wrote that for a reason. It means they are significant. Now, what about other zeros? Other zeros like these guys over here. These zeros here need to be there. These zeros there tell you how big this 2 is. They tell you whether this is in the thousands place, the tenths place, the 10,000s place, or an etc. If they're trying to communicate how big that number is, they're trying to tell you accuracy. If they're trying to tell you accuracy but not precision, these zeros are not significant. In conclusion, only zeros that communicate precision only. Oh my goodness, I can't spell precision only are considered significant. So you can go through each of these examples and take a look at what are the function of these zeros. Are they communicating precision or are they communicating accuracy? If they're communicating precision, that means they are significant. That is a conceptual understanding behind all these rules, and that is why you need to watch the previous video before watching this one. Hope you enjoyed this. If you have more questions, you can come ask me in class. If you need to rewatch the video because I talk too fast, then feel free to do so as well. Well, I will see you guys next time. Thanks for watching.